Well, it's Miss Sorrells again, here to teach you another important concept. This concept is going to be factors and greatest common factor. They go together. This is really important. This will help us when we get later on the road when we get to fractions and we need to learn to simplify fractions. We're going to start with our 4 goals, so just read along with me right now. The first one is just to be able to define. So be able to explain what a factor is and then tell me what greatest factor means. You also need to know that GCF represents greatest common factor. It's often referred just to as GCF. Excuse me. Second one is to list all the factors of a number, and we're going to use a T-chart. That's our strategy. I will show you in a minute. The third one is going to be to design a Venn diagram to determine the greatest common factor, or GCF. Again, I will show you. And number 4, you need to determine when to use the greatest common factor to solve a problem. This is probably the most important, okay? To be able to tell the difference between greatest common factor and least common multiple is very important. We said that LCM was used to decide when something needs to happen at the same time again, or occur at the same time. So you will learn what greatest common factor is in a minute. Again, you know the deal, you know the drill. Rewind, pause. If you need to, fill out the form at the end. Here we go. Goal number 1 is to define a factor. Okay? A factor is a number. It's not a hashtag, it's a number sign. A number multiplied by another number to get a product. When you multiply 2 factors, you get a product, which is your answer. An example of this would be, let's just say 3 multiplied by, okay, this dot, why does it keep doing that? I guess it doesn't like the dot. We'll try a little x. Alright, I guess it doesn't like the dot. Okay, so 3 times 4 equals 12. This is a factor, just put an F. This is a factor, and this is a product. So factor times factor equals product. Okay, the greatest common factor, kind of like least common multiple, you've got this word common, which means the same. We've got a factor, which we know we're going to be, is when you're multiplying. And then greatest is obviously another word for biggest or largest. Okay, so if you were to compare 2 or more numbers, it's going to be the factor that they have in common or the same, and this time we want the biggest number. Okay, the largest factor that 2 or more numbers have in common. Okay, let's look at, let's use 14 and let's use 21. Okay, this is what a T-chart is. Follow along here. So you put the number that you've been given at the top, and then you draw a big T underneath. Okay, the T is where you're going to be labeling the factors. Okay, so you need to use your divisibility rules here. So we know that 1 is always a factor because you can always do 1 times the number itself. Alright, then you're going to move to 2. 2 I know will work in here because it ends in an even number. And 2 times what equals 14? Well, 7. Okay. 3 will not work. 4 doesn't work. If you list multiples of 4, it's 4, 8, 12, 16, so it skips over 14. 5 doesn't work, doesn't end in a 5 or a 0. 6 doesn't work, and then you would loop back to 7. Okay, notice I didn't put all the numbers that didn't work. You don't want to do that because then you have to end up going back and crossing off, and if you forget that step, then you think that 3 might be a factor, which can mess you up later. Okay, so 21 is 1 in 21. Just because it's odd doesn't mean it's prime. Don't forget 3 times 7. Okay, and then nothing else works. So you're same thing. You're going to look at your two lists and say, okay, yeah, they both have 1s, but we want the largest. We want the largest number. Okay, there's a 2 here. There's not a 2 here. That's not a choice. There's a 14 here. No 14 in this list. There's a 7 here, and there's a 7 here. It's the biggest number they have in common. So their greatest common factor is 7. Okay, so again, this is a T-chart. It's our strategy for just listing factors of any given number, and then this would be comparing the two, so the greatest common factor. Alright, here we go. Keep practicing. There's some more T-charts. What I want you to do, I'm going to do 40 with you, and then I want you to pause and do 28 and do 64. Again, be a risk taker here. If you don't try it, you're never going to be right. And if you do try it, you do have the possibility. Okay, so I need you to go ahead and after this one, you need to pause and try the problem. So we know 1 in 40. We know 2 will work because it ends in a 0. It's an even number, and it's 2 times 20. Okay, 3. The trick for 3 is this. You add your 2 digits, so 4 plus 0 is 4. And 4 is not divisible by 3, so we know that won't work. Okay, 4 will work because 4 times 10 is 40. 5 will work. It ends in a 0. 5 times 8. 6 will not work. 7 will not work. And then it would go back up to 8. Okay, and so it would loop around down here, and we end up repeating. So no need to do that. All right, so that would be all the factors of 40. All right, I want you to pause the video. I want you to try 28. And I want you to try 64, and then once you're done, you click play again, and then I'm going to work out the problem so that you can hear. Okay? Go ahead and do that. Alright, thank you for giving it a try, being a risk taker. So 1 times 28, 2 times 14, 3 doesn't work, 4, whoops. Come on. There we go. 4 times 7. 5 does not work. It ends in an 8. 5 can't go into that. 6 doesn't work. And then we'd be back up 7 and have to go up. So I'm done. If you did this, give yourself a check plus. If you didn't get all of those, make sure you add them so that you have the correct ones. Alright, an even bigger number here. 64. Alright, so we know 1 times 64. We know 2 times 32. Alright, you might not know 2 times 32 off the top of your head. You might know that it's going to be divisible by 2 because of it ending in a 4, but you might have to come to the side here and do some side math and figure what it exactly is. So 2 goes into 4 2 times, whoops, and then you're good. So then you've done it. Okay, so again, you might not know them off the top of your head, and you're going to have to be willing to go ahead and do that extra division. Alright, 3 does not work. 4 times 16. So this one is one you probably didn't know either, and so you would need to come down here and go, let's see if 4 goes into 64. Okay? And then say hi to the class, Garrett. Say hi. Say hi. I'm recording. Say hi. Garrett just walked in. Say hi. Just say hi.
What do you mean?
What do you mean? Just say hi. Say hi, class.
What do you mean?
He doesn't get it. He doesn't know we're recording. All right, we're going to continue. Okay, so 4 times 16.
Are you seriously recording?
Yes, Garrett, please leave. All right, 64 does not work with 5. Let's see about 6. Okay, 6 doesn't work. 7, and then we know 8 times 8 is 64. And then you know you're done because 8 just would loop back around to 8 and you'd go back up. Okay, so if this is what you got, check plus. Great job. Okay, so that's just goal 2. That's just listing the factors. Now we're going to practice some GCF, which is goal 3. Woo, what is all this stuff? Here's your Venn diagram. Okay, this is a way to compare and visually see the differences and similarities. Okay, a Venn diagram works where all things that are similar go in this spot right here. The differences go here. Okay, so I want you to do goal 1 and list all your factors, and then you find the ones that are the same and you'll list them right in the middle, and then you can pick the biggest number. Okay, so 1 times 28, 2 times 14, 3 doesn't work, 4 times 7. Okay, and we've already done these, so that's why I'm going quickly. 5, 6 doesn't work. Okay, so I've listed all those. 1 and 64, 2 and 32, 4 and 16, and 8 and 8. Okay, so let's look. They have a 1 in common. Let's list it right here. They have a 2 in common. List in the middle. 4. Whoop, they both have 4s. They've got a lot in common. Let's jump right here. 7. They do not have a 7 over here. A 14. No 14 in this list. A 28. No 28 in this list. So you can clearly see that the biggest one is 4. So your GCF between 64 and 28 is 4. Okay? Alright, so now you've seen the Venn diagram and where to list the factors and where to list the similar factors or the common factors. So I want you to pause. I want you to try 9 and 27 and then press play again and you can check your answers. Alright, good luck. Alright, here we go. 1 and 9, 3 and 3. Quick and easy. 1 and 27. Fix that too. 3 and 9. 4, no. 5, no. 6, no. 7, no. 8, no. And then I'd go back up to 9. Alright. They've both got a 1. And they've both got a 3. There's a 3, and then there's a 9 here, and there's also a 9 here. Okay, don't just stop at the 3. You have to go all the way through the list. So your GCF, or the greatest number, the largest number they have the same, is 9. Okay. Great work. Let's finish up with an example of a word problem. Wow, a lot of writing. Okay, goal 4, determine when to use the greatest common factor. Alright, so we're going to use some key words here that you would see in a word problem. The same. You want an equal amount. Okay, this is a huge one. Greatest, because it says it in the word greatest common factor. If you're trying to find the biggest amount that you can have, it's going to be the greatest common factor. Groups. These T-charts down here, those are you dividing and figuring out factors. So if you're going to split something up into groups, that is definitely GCF. Okay, dividing. If you want to divide up evenly. Biggest, so that goes again with greatest. If you're going to split something, if you want equal something, and then we like to think of it as making things fair. Alright, here's your problem. 1, he's throwing a party and he's going to make party bags for his guests that come so that he can thank them. Alright, you know you go to the party for the party bag. All right. 16 chocolate bars and 12 bags of Skittles. How can one split, keyword, the party bag so that every bag has the same amount of chocolate bar and Skittles? So how many bags can he make if this is it? And they have to be even. All right, so we've organized it here with our Venn diagram, which is one of our goals, goal 3. Okay, we've labeled that this over here is going to be Skittles and that the left side is going to be chocolate bars. All right, chocolate bars. What number went with chocolate bars? 16. Skittles, 12 bags of Skittles. Okay, and I know this is GCF because I'm trying to make the same amount and I'm dividing them up. I'm splitting up the candy between all the friends. Okay, so let's go 1 and 16, of course. 2 will work. 2 times 8. 3 doesn't work, but 4 does. And I know that I can stop because it would go 1, 2, 4, and then we'd go back up here to 4. Okay? Can't do anything in the middle yet because I haven't done 12. 1 and 12. 2 and 6. 3 and 4. And I'm done. Alright, let's list common ones. There's a 1 here and a 1 here. So I can put it over here. There's a 2 here and a 2 here. I can put it here. There's a 4 on both sides. It does not matter that the 4 is on the left side of the T-chart here and the right side over here. That doesn't matter as long as they're in the list together. Okay, there's an 8 here. No 8 with Skittles. 16 and no 12 with Skittles. Alright, what's our GCF? 4. Okay, so what does that mean? That means he can make 4 bags. Okay? He can make 4 total bags or 4 groups of the candy. The other question you might get is, okay, well, how many Skittles are in each bag? And how much chocolate, I'm going to just abbreviate, does each person get? Because that's what you really want to know. How much candy will I get if I go to the party? If he doesn't give me enough, I'm not going. Alright, kidding. Here we go. Skittles. Let's look at the Skittles side. Here's the groups. Here's what we said, 4 bags. And the factor that goes with it is the one that tells you how many bags are there. So there were 4 groups and each bag had 3 bags of Skittles. Okay, because the 3 and the 4 are together to make 12. Okay, over here we said, okay, there's 4 bags, and in each one, the 4 goes with it, so there would be 4 chocolate bars. So each bag would have 3 bags of Skittles, 4 bags of chocolate. He hooks it up. Okay, if one puts 4 chocolate bars and 3 bags of Skittles into every party bag, he is able to make 4 bags total. Okay. All right. If you have any questions, of course, please make the comments. I did go pretty fast, so if you need to go back because you were busy trying to get the correct notes down, please do so. Also, make sure your form's filled out completely, and the hardest part, get it to class tomorrow, children's, and again, make sure you submit the online form. All right, thank you for your time. Have a good night. See you later.